Welcome to the mathematical machinery of uncertainty. Until now, your study of probability has likely focused on isolated events, like drawing a single card, rolling a die, or picking a colored counter from a bag. While useful, these basic models fall short for complex systems where we need to analyze the entire landscape of possible outcomes simultaneously. This unit bridges the gap between basic probability and formal statistical modeling. You will learn how to map out every possible result of a discrete scenario, measure its long-term average, and quantify its predictability. Mastering this means shifting your mindset from calculating single fractions to analyzing entire distributions of data. It is a critical pivot point for your A-level studies, laying the groundwork for hypothesis testing later. We begin with discrete random variables and their probability distributions. A discrete random variable is a quantity whose value depends entirely on chance, but can only take specific, countable values, like 0, 1, 2, or 3, rather than any value on a continuous scale. To model this, you will construct probability distribution tables from descriptive word problems. Your absolute first instinct in any exam question must be to check that the probabilities in your table sum to exactly 1. Cambridge examiners love to test this by hiding an unknown constant, often k or c, inside the table. You will use that sum to 1 rule to form an algebraic equation, solve for the constant, and unlock the rest of the question. Once your distribution is built, you need to measure its key characteristics. Expectation is the long-term average outcome of your variable. Variance measures how spread out those possible results are. These are highly structured exam questions. Examiners award vital method marks for showing your correct summation steps. You cannot just write down the final answer from your calculator. Your algebraic working is the answer. A top candidate writes down every intermediate step. Finally, we apply these general rules to a specific, highly useful scenario, the binomial distribution. This models a fixed number of repeated independent trials where every trial results in either a success or a failure. You will calculate exact probabilities for specific outcomes and tackle tricky cumulative phrases like at least 3 or fewer than 5. An A-star student instantly translates these English phrases into strict mathematical inequalities, ensuring they include or exclude the correct boundary values. We will also cover the mathematical shortcuts for finding the mean and variance when a model is strictly binomial. Instead of drawing a massive table and summing the rows, you can use streamlined formulae. The expectation is beautifully simple. Just multiply the number of trials by the probability of success. But remember, you cannot use this shortcut for a generic distribution. It only works if the variable is strictly binomial. By the end of this unit, you will have a complete toolkit for statistical uncertainty. You will be able to construct distributions, calculate expectation and variance, and confidently apply the binomial model to real-world scenarios. Remember, always verify your distributions sum to 1, parameterize your models early, and state your assumptions clearly. You are now ready to dive into the first topic, discrete random variables.